Hello wonderful person, this is Anton, and today we're going to be discussing a potential resolution to a strange mystery that happened to our planet approximately 1 million years ago. The climate of our planet transitioned from having relatively short cycles to relatively long cycles, dramatically affecting the glaciation of our planet, making the actual ice ages last much longer. And this mystery, known as the Mid-Pleistocene Transition, or MTP for short, is one of the stranger events when it comes to the climatic changes on planet Earth. Something really dramatic happened on our planet right around this time right here, creating very different cycles with extreme changes in temperature and thus affecting the evolution of life on our planet as well. So this is something that scientists have been trying to resolve for many decades now, and it looks like this one paper right here might have finally found a resolution. And surprisingly, this doesn't actually involve anything catastrophic or anything extreme. The explanation is very counterintuitive, but extremely interesting. And so let's discuss this in a little bit more detail and also talk a little bit more about how the various cycles in regards to climate change transformed in the last 2.5 million years. And let's actually start with a graph that shows us the geologic temperature of planet Earth, or basically the temperature, the average temperature in the last few millions of years. And here we're mostly interested in this up to basically this point. The era known as the Holocene, and especially some of the modern changes, is a completely different topic that has been discussed in some of the previous videos. Now first of all, take a look at the era known as Pliocene. This was between approximately 5 and 2.5 million years ago, and during this era the temperature was relatively stable, but it did decrease just a little bit right around this point right here. And this is the beginning of the era known as the Pleistocene, where the climate suddenly transformed and the temperature was regularly going up and down in very cyclical manner. And so I guess one question is, what exactly happened here in order for the planet to suddenly start cooling down so much? Well, there are quite a lot of explanations, but two of them sort of stand out, with one of them specifically making the most sense. Right around this time, the two continents, North and South America, essentially became joined by what's known as the Isthmus of Panama. And this closure disrupted a major current around the planet that was sort of maintaining the warm temperatures on planet Earth, while at the same time creating some other currents, such as the Gulf Stream, that's sort of responsible for keeping certain regions in North Europe slightly warmer. And this major disruption slowly started to cool down the planet to the point where we now start having these cycles known as glaciation cycles. Or in other words, this was the beginning of the Ice Age. And for approximately 1.5 million years, all of these cycles would usually last about 41,000 years. So basically you would have a glaciation followed by the thawing going into the other glaciation. But the actual glaciation periods were more or less mild, and the temperature changes were not really that dramatic, with the glaciation cycles in this case being caused by the other cycle known as the Milankovitch cycle. At least that's the assumption today. There's a pretty good article from NASA that I'm posting in the description below that explains Milankovitch cycles in detail, but just to quickly summarize this, as the planet orbits around the Sun and as it sort of spins around as well, it experiences various changes in both its rotation and the orbit. For example, there is a slight change in eccentricity that happens roughly around every 100,000 years. There are also these wobbles, known as changes in obliquity, that happen every 41,000 years. And then we also have axial precessions, which usually are every 26,000 years. Now altogether all these cycles produce various variations in temperature that today are believed that were responsible for all of these glaciation periods in the beginning. Which is also why initially the cycle was 41,000 years. But then somewhere right here, approximately 1 million years ago, there was a sudden dramatic change in the way cycles progressed. First of all, they increased to 100,000 years, which technically would be equivalent to the eccentricity cycles. But at the same time, the temperature changes started to really go up and down way more dramatically. And as a result of this, our planet started to decrease in temperature even more, and the actual ice ages became way more extreme. And this graph right here demonstrates this pretty well. The initial glaciation cycles would only change the temperature by about maybe 5 degrees, but some of the latest ones would change it by nearly 15 degrees between the hottest and the coldest periods, which naturally created a mystery that nobody knew the answer to, with the mystery itself today known as the Mid-Pleistocene Transition, or MPT. Now the actual change was not instant, it was not basically something catastrophic, suddenly changing everything on the planet. it most likely happened sort of gradually, and it started approximately 1.2 million years ago, with the transition itself finishing around 0.7 million years ago, at which point all of the cycles were at their extremes. And on top of this, a lot of these cycles were very unpredictable, extremely asymmetric, and were just way too different from one another, which of course was really difficult to explain. And so the conclusion that many scientists came to is that, well, maybe something dramatic happened on a planet approximately 1.2 million years ago in order to cause this particular transition and this shift. But obviously, nobody really knew what exactly happened. And so even though the initial assumption was that, well, maybe the Milankovitch cycles changed, or maybe something surrounding the solar system caused these cycles to be more extreme, none of this really made sense because it would be very, very difficult to explain, and there was just not enough evidence. As a matter of fact, there is absolutely no evidence that these cycles ever changed in the last few millions of years. But there was actually evidence that the ocean currents changed. And this evidence sort of led the scientists behind the paper, you can find it in the description, to finally sort of explain what might have happened during that period. And the overall conclusion is that, well, it's the ocean currents that changed over this period of time because of something happening in the northern Atlantic. And this of course makes sense, because as I mentioned before, for example, the Gulf Stream is actually responsible for carrying all of this warm water all the way to the northern hemisphere, where it does warm up a lot of the region. And so if for some reason suddenly the current itself stops, or if it's affected in some other way, it can dramatically shift the climate of the planet. But what exactly caused the current to stop or to transform in some way? And so the scientists in this paper decided to see if there was any major change to some of the seafloor in the North Atlantic, and they did this by analyzing some of the ancient sediment present in the region. And what they discovered is that during that time, approximately 1.2 million years ago, the ice sheets started to stick to the floor a little bit more. And because of the sticking to the seafloor, they started to accumulate and build larger and larger ice formations, which eventually produced much larger glaciers, which increased in size every single cycle. Whereas prior to this, the seafloor was much more slippery, allowing some of the glaciers to move across and to not really build very large structures. And so as the glaciers grew in size and became bigger and bigger, they actually did two things. First of all, they completely disrupted the Atlantic current. Essentially, the heat could no longer reach some of the northern regions, which then led to even more glaciers. And at the same time, because there were more glaciers now, they also ended up reflecting more light, cooling down the planet even further. But because this was following the Milankovitch cycles, all of this would eventually start sort of reversing and the planet would start warming up again. But with every single cycle, because the seafloor became more and more rigid and attracted even more ice to stick to it, all of this would just end up producing larger glaciers with every single cycle until one of the last ones, where the temperature changes were at their peak. And so in other words, by changing the seafloor over time, which was most likely caused by the previous glaciation cycles which slowly disrupted the smoothness of the seafloor, it eventually led to a buildup of a dramatically larger glaciers all across the northern region, which eventually culminated in the production of some of the largest ice sheets our planet has ever seen, while at the same time producing some of the lowest levels of water, opening up certain regions where eventually our ancestors could traverse and sort of colonize various continents. During that last glaciation period, that's essentially when our ancestors were able to move from Africa to Europe to Asia to North and South America and to even Australia. And that's because during the glaciation period, the water levels dropped so much that it became extremely easy for a lot of our ancestors to just walk across from, for example, Asia to Australia. And so this mystery, as I mentioned in the beginning of the video, had nothing to do with any major catastrophe. And in reality, it was all due to the crystalline bedrock that was essentially created by the continuous grinding of ice, turning the slippery continental soil into something much harder and something that was easier to stick to, which by itself is actually a pretty important discovery. First of all, this highlights that the climate change is not always dependent on the atmosphere, or even on the illumination from the sun itself. In this case, the climate change was caused entirely by changes in the ocean, and specifically the changes on the seafloor, something that took approximately 500,000 years to transform. But it also sort of highlights how little we still understand about the changes on our planet, and how this is actually a really important topic to try to study in detail and to try to understand because of these dramatic changes that can completely transform the planet. But also to some extent it helps us understand our ancestry. It helps us learn more about what our ancestors most likely did, and how they ended up traveling across the planet, and how they survived all of these ordeals. And so definitely a pretty interesting and a pretty important discovery, and something that we'll most likely talk about again in some of the future videos. But for now, there's actually one more thing I wanted to mention that I was going to mention in the beginning. The potential other source of the initial climate change approximately 2.5 million years ago. There are actually signs of at least one more source that might have dramatically cooled down the planet and continuously cooled down the planet for the past 3 million years. That source is a nearby supernova. And the signs of this are both in outer space, but also here on Earth. I've already talked about this in some of the previous videos, but essentially in the last few years scientists have been discovering signs of an iron isotope that's usually found in supernova. And all of these samples were coming from ice cores that were approximately 2.5 million years old. Likewise, the astronomers have discovered this area around the solar system that's sometimes referred to as the local interstellar cloud, and this was definitely created by some sort of a supernova. And for the past 2.5 million years, the solar system was actually traveling through this. And it's really only now that we might actually move out of it and possibly move into the other cloud. Now, on the one hand, all of this could potentially explain why the planet overall started to decrease in temperature. But at the same time, because we now left the cloud, it might explain why certain glaciation cycles kind of stopped. Now, a lot of this is still a bit of a speculation, and there is still just not enough evidence to say any of this for certain, but it is one of the potential explanations to some of the climatic changes in the last few millions of years. And specifically the glaciation cycles, and also some of the changes in, for example, forests. So a typical supernova, if it happened relatively close to us, it does have a potential to remove a very large part of the ozone layer, which protects us from dangerous radiation. But once again, we've talked about this in some of the previous videos, so do check it out if you want to learn more. Anyway, we'll discuss this in some of the future videos, but for now, check out the paper and all of the relevant links in the description below. Thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.